12.4 Measures of Dispersion. So measures of dispersion are used to measure the variability of data, including the spread of data. Range. The range is the difference between the highest and lowest values and indicates the total spread of the data. Range is highest value minus lowest value. So determine the range. The amount of carbohydrates in grams of 10 different types of yogurt is given. Determine the range of these data. Should be of this data. Fix that for next semester. Alright, so the first thing that we need to do is figure out our highest number and our lowest number, and then subtract, and that's it. So our highest number is highest value. So highest value, if you look at them all, is 29. So for range, we'll have 29 minus, and then our smallest number. So our smallest number is 8. So our spread of the data, our range, is 21. Alright, standard deviation. So standard deviation measures how much the data differs from the mean. It is symbolized with S and is calculated from for a sample. So this is, let me rewrite it in white. We have S equals the square root summation of x minus bar x squared all over n minus 1. That seems like a lot. That seems really scary of a formula to know. You don't even need to look at the formula. We just break it down into steps. That's it. Okay, so our first step to find standard deviation, you want to determine the mean of the data. Because remember, that's what bar x is. That just means the mean. Then you make a chart having 3 columns. So the first column is data, the second column is data minus mean, and the third column is data minus mean squared. You list the data vertically under the column marked data, subtract the mean from each piece of data, and place the difference in the data minus mean column. Subtract the values obtained in the data minus mean column and record these value in data minus mean squared column. Determine the sum of the values of data minus mean squared column. Divide the sum obtained in step 6 by n minus 1, where n is the number of pieces of data, and then we square root it. I know that seems like a lot, but when we actually break it down, it's very, very straightforward, okay? And I'll walk you through the whole thing. So Vet recorded the following lifespan of selected Labradors, 7, 9, 11, 15, 18, 12. Determine the standard deviation of the lifespan. So our first step is to find the mean, which is that little bar x thing. And to find the mean, this is the math talk, like the really mathy explanation of it. Summation of x over n. All that means is we add up all our numbers, so 7 plus 9 plus 11 plus 15 plus 18 plus 12. And then we divide it by how many numbers we have. We have 6 numbers. So we simplify to get 72 over 6, which is 12. So that is the mean, which is bar x. Alright, this is step 2. Step 2 is to create the table. So you see how we have 3 columns. Our first column is data, our second column is data minus mean, our third column is data minus mean squared. And then our third step is to list the data. So to list all this data, that's our third step. Our fourth step is to take the data and minus it by the mean. So we take our data, so 7, 9, 11, 15, 18, 12, and then we're going to subtract it by the mean. The mean is what we found here of 12. So 7 minus 12, 9 minus 12, 11 minus 12, 15 minus 12, 18 minus 12, 12 minus 12. And then what we're going to do is we're going to actually subtract it. So 7 minus 12, we get negative 5. 9 minus 12, we get negative 3. 11 minus 12, we get negative 1. 15 minus 12, we get 3. 18 minus 12, we get 6. 12 minus 12, we get 0. Now, sorry, I'm getting ahead of myself. I'm not writing down my steps. That was our fourth step. Our fifth step is to actually square it. So that's what we're going to do to each of these values, is square them. That's going to lead us to our sixth step. After we square them, we're going to add them up. So we square them. Negative 5 squared is 25. Negative 3 squared is 9. Negative 1 squared is 1. 3 squared is 9. 6 squared is 36. 0 squared is 0. We're going to add up all of those numbers. So 25, 9, 1, 9, 36, and 0. And we get 80. That brings us to our seventh step. So our seventh step is to take the total in step 6, and then we divide it by n minus 1. And n is the same n as we found the mean. It's the number of data that we have. So see, we have 6 values for our data. So that's what we're going to plug in. So we have our total, which is 80, over 6 minus 1, because we have 6 numbers. We have 6 pieces of data. We just keep simplifying to get 80 over 5, which is 16. Our last and final step, step 8, is to square root what we got in step 7. So we take the square root of what we got in step 7, which is 16. So the square root of 16 is 4. So the standard deviation is 4. Now what that means, my best possible explanation where it's not too mathy, it might make sense, it might not, is we found the difference between the average and how different it is from it's a little hard to explain. Okay, bear with me. So it's how much the data differs from the mean, meaning it's kind of like how much spread is in between everything. How much value is in between each piece of data. That's kind of what we're finding. When you start to graph these things in statistics, it's all going to click, but I can't show you how to graph because we don't know how to graph this yet. But you will learn in statistics if you take it, and it'll kind of all start to click together, but it's the spread of the data. Okay. All right, you're probably asking yourself, that's a lot of work. It is. So the next one, we'll do it by hand, and then I'll show you how to do it with your calculator. All right, the following prices are 9 stocks on the New York Stock Exchange. Determine the standard deviation of the prices. So our first step is to find the mean. Remember, that means bar x, and that's that fancy formula of summation of x over n. So all that means is just add up all your numbers and divide by how many numbers you have. So we have 17 plus 28 plus 32 plus 36 plus 50 plus 52 plus 66 plus 74 plus 104. All right, and then we divide it by how many numbers we have. We actually have 9 pieces of data. So we add everything up, we get 459 divided by 9, and it is 51. So that is our bar x, that's our mean. All right, now our second step is to go ahead and do the chart. So we have 3 columns, data minus mean squared. Our third step is to list the data. And then after that, we're going to subtract data minus mean. So we have our mean of 51. So we have the data. So you don't actually have to rewrite 17, 28 or anything like that. What you can do is just do 17 minus 51, 28 minus 51, 32 minus 51, 36 minus 51, 50 minus 51, 52 minus 51, 66 minus 51, 74 minus 51, and 104 minus 51. And then we can equal it, because we're going to square it. So when we figure out those values, we'll just put them in the data minus mean squared column. So 17 minus 51 is negative 34. 28 minus 51 is negative 23. 32 minus 51 is negative 19. 36 minus 51 is negative 15. 50 minus 51 is negative 1. 52 minus 51 is positive 1. 66 minus 51 is positive 15. 74 minus 51 is 23. And 104 minus 51 is 53. So that was our fourth step, was to subtract it. Now our fifth step is to square it. So we're going to square each of these. Alright, now we square each of these values. So negative 34 squared is 1156. Negative 23 squared is 529. Negative 19 squared is 361. Negative 15 squared is positive 225. Remember, when you square something, it's always positive. So if your calculator is giving you a negative, make sure you wrap it in parentheses. You want to plug it in exactly the way it looks. So wrap it in parentheses and then square it. All right, negative 1 squared is positive 1. 1 squared is 1. 15 squared is 225. 23 squared is 529. And 53 squared is 2,809. Our sixth step is to go ahead and add all these totals. So when we add up all of those numbers, we get 5,836. All right, so seventh step is to take our total. So it's total over n minus 1. The total was 5,836 over n. N is how many pieces of data we have. We have 9 numbers, so 9 minus 1. 5,836 divided by 8, and we get 729.5. Now our last step is to find our standard deviation, and it's the square root of step 7. So the square root of what we got in step 7, we get our standard deviation is approximately 27.01. Alright, I'm going to show you how to do standard deviation with the Texas Instrument. A lot of calculators can do this, but I only know how to do it using the TI-84. But if you just Google your calculator, so like if you have like a TI-30, Google TI-30 standard deviation, and I bet there's hundreds of videos, thousands of videos on YouTube that can teach you in a second. That's how I learned how to do standard deviation at TI-84. It's super duper simple, so I know you can do it. You are allowed to do this, because if you're going to stats, that's all stats is knowing how to read word problems and then plug it into a calculator. Of course, it's way more than that. It's a lot of probability and stuff like that, but it's really knowing how to use your calculator. Alright, so these are the steps. I'm actually going to walk you through them so you can see me doing it on a calculator. And the first thing you're going to do is you're going to hit your stat button. Always make sure your lists are cleared, and I'll teach you how to clear your lists and then actually plug all of this in, okay? Alrighty, sorry, I'm just trying to make my screen work for me. There we go. Alright, with our handy dandy calculator, the first thing we're going to do is we're going to hit the stat button. Stat button is right next to the arrows. So we hit the stat button, and then we want to make sure we have nothing in our list. So press 4. And to clear our list, we need to clear our list 1. So you press second 1, enter, and then we have to do it again because most of the times you use 2 lists. So let's clear out our second list. You can have a lot of lists. So you see how it says L1 in blue, L2, L3. So if you look at number 1 up above it, it says L1. If you look at number 2 up above it, it says L2. So that's what we're clearing those lists out. So let's clear out list 2. We hit stat number 4, and you hit second 2, and that'll clear out our list 2. Now what are we clearing out? I'll show you in a second. Hit stat again, and you're going to hit edit. So hit enter, and that's what we cleared out. We cleared out L1 and we cleared out L2. So a lot of times we forget stuff is there, so we just learn to clear it out to begin with, and then this way we know we can just plug in the numbers. So we only have one list of data. That's it. We're only working with one thing, the New York Stock Exchange. So we're just going to put it in L1. So 17, to see it, press down. 28, 32, 36, 50, 52, 66, 74, 104. Make sure you have enough numbers. We have 9 numbers, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers. We're good to go. I didn't forget any numbers. So now we can go ahead and find the standard deviation. So hit the stat button again, and you're going to scroll over, use your right arrow, go to stat. It should already be on number 1, one variable statistic, so press enter. Scroll down to calculate, press enter. There we go. So on the top it says bar x, that's our mean. Then we have summation of x, so that's if we add up all the numbers. This is if we add up all the numbers and square it. This is how many numbers we have. If we keep scrolling, you see how we have Q1. We also have the median, which is Q2, and we have Q3. So it actually gives us our quartiles too. So our standard deviation, so SX, that's standard deviation of X, is 27.009, something, we rounded it, remember? So this one right here, EX squared, that's if we took all the numbers and squared it. Remember when we were doing the table? And then that's all our numbers when we add them. Cool, right? It's all the same answers we got. So you can do this every time you want to find standard deviation. Remember, your standard deviation is SX. That's going to be your standard deviation. You might have to watch this part a couple times. Definitely practice on the previous example so you know that you're plugging it in right. But if you are going to stats, get used to standard deviation. It's like within the first couple weeks of stats. And if you already know how to do this with your calculator, you're already ahead. So watch that part a couple times. Do it with example 2. Make sure that your standard deviation, remember standard deviation, it's going to be SX on your calculator. Make sure you're plugging it in right and getting all the same answers, and then I highly suggest you do your homework in your test and anything on the final to do a standard deviation or quartiles or finding your mean. You no longer ever have to use your hands or do it by hand. You can find your mean here. If we scroll up, our mean is X bar X. You can find your standard deviation. You can find your quartiles, okay? So use your calculator for that test and for the final.